This is a video on quadratic equations, and there's a family of quadratics which we can consider. So quadratic equations and let's start off with binomial. So that's of the type x squared plus 4x. There is trinomial, monic. That's of the type x squared plus 7x plus 12. There's trinomial, non-monic. So an example of a trinomial non-monic would be 6x squared minus x minus 12. There is a difference of two squares. Let's do 9x squared minus 100y squared. It's gone off the page. We have perfect square. Let's do x squared plus 2x plus 1. And we also have, let's do a hidden one, hidden factor. Let's do, I don't know, x squared minus 2x minus 1. There's other hidden ones. We could do 18x squared minus 200y squared, and let's throw in another one. Why not do negative 6x squared minus plus x plus 12. Okay, I'm not having much luck fitting all this on the page. Let's see if I can move this up a bit. Okay, so here's my hidden ones. Let's see if I can fit all this on the page. Okay, success. So it will be a really good revision for you to see if you can factorize these. So pause the video and off you go. Okay, so hopefully you factorized all these. So when we factorize something, we take out the highest common factor and we divide by the highest common factor. So the highest common factor here is x. Take that out to give this. On this one, we look at factors of 12, where we've got 1 and 12, 2 and 6, 3 and 4. Hope you can all see that 3 plus 4 is equal to 7. And we can expand that to show that it gives our original monic quadratic trinomial. Okay, so let's do the non-monic trinomial next. I'm going to shift this up. So the general form of a quadratic is ax squared plus bx plus c. If a is equal to 1, we refer to this as monic. If a is not equal to 1, we refer to this as non-monic. It's 3 terms, so trinomial, 2 terms, binomial. Okay, so the first thing we need to work out is the product of A and C. So the product of A and C here is 6 times 12, which is 72. So we're going to look at factors of 72, which add or subtract to give negative 1. I hope you can all see that 8 times 9 is 72. So let's write our original quadratic out again. 6x squared negative x negative 12, and we partition it's negative 1x, so we're going to get 6x squared minus 9x plus 8x minus 12. We can factorize both binomials, so we're going to take out a 3x there to get 2x minus 3, and we should get the same common factor. If we don't, we know we've gone wrong somewhere. So we take out 4 there to get x, 2x, subtract 3. Common, 3x plus 4, 2x, subtract 3. Okay, the difference of two squares, a little bit more straightforward. Difference of two squares always follow x squared minus y squared, or y squared minus x squared. We can also insert numbers here as long as they're squares. So if we factorize this, we're going to get 3x, subtract y, and 3x plus 10y. Okay, so let's move on to our perfect square. Perfect squares are analogous to, we have a square there, all sides are equal, so the area of this square is going to be, and that's what we mean by a perfect square. We can expand it by squaring the first, doubling the product, and squaring the last. So the factorization of this is going to be x plus 1 squared, and we can use the distributive property to check the result. Okay, so we've got these lovely hidden factors. So we can factor out a negative 1 here to get x squared plus 2x plus 1, and then this is just our perfect square. Here we can factor out a 2 to get 9x squared minus 100 y squared, and then that's just a difference of two squares. And this lovely thing here, we can just factor out a negative to get 6x squared minus x minus 12, and this is the same as the factorization we did before, so we're going to get 3x plus 4 to x minus 3. Okay, so let's see if I can get this on the page. Lift my camera up. Okay, so there's our family of quadratic equations.